Hi guys, my name is Kirill. I am gameplay programmer and I continue talking about features I implemented for the game StrikeNet. One of the coolest features I implemented for this project was server-side rewind algorithm, shortly SSR. Basically, it's a cool technique for lag compensation. To start talking about what it is and how it's implemented, first I want to describe a problem. Let's say that we have very laggy clients with high ping, for example 1000 milliseconds. Well, of course, you may say that in modern shooters it's not real, but I want to use this value for better demonstration purposes. We could simulate such lag if we set up package lag equals 500 in default engine.ni in Unreal. Imagine that you are camping and finally you found a good sniper spot. You are aiming at enemy with your sniper rifle, click fire and wow, nothing happened. You're definitely sure you made that hit. Let's try again. The same zero result. So what happens briefly is that ping on your opponent machine is so high, it takes so long time to replicate his data to the server and from server to your machine, so that when you click fire and your hit request is proceeds by the server, the coordinates of opponent character on your machine are really different from coordinates on server version, so you miss. I made quick blueprint variables to enable the SSR algorithm for each weapon in the game. Now we enable it for the sniper rifle, repeating the example again. And tada! We're killing an enemy once again. Yeah, as you can see, it works. Let's jump into an implementation. We preserve 4 seconds frame history for each version of a person on server side. In order to optimize memory and CPU performance, we collect location of box collisions, not skeletal mesh. Well, in a harsh reality, a line trace is not so accurate and there is no really need to collect bones with locations. There are 3 weapon types: projectile with explosions, hit scan is just a line trace with no physics applied. Good example is a sniper rifle in our game. I'm going to discuss hit scan algorithm in depth, and to speak about others, I will cover only differences since their implementation uses the same approach. So let's jump in finally to C++. First we check if we are on a server or not. If we are on server, ping is 0 and we could proceed damage logic with no problem at all. If we are on a client, we will send server RPC with current hit time and hit enemy character. In order to handle SSR logic, I created custom lag compensation component which provides RPC server score request. It triggers main logic server-side rewind method which can be separated on 2 parts. First is get frame to check. It's searching for needed frame package structure in a frame history. Target frame package contains coordinates of box collisions for enemy character in the world. The second part is confirm hit. It makes a line trace from our weapon socket location to target location and see if there is a hit with enemy character box collisions. Let's discuss each method in details. First, we will take a closer look at how get frame to check works. Frame history, it's a double linked list. We are searching for 2 closest frames in while loop using our hit time. After we find out the closest frames, we interpolate between them and return the result. Second step is confirming a hit. We move collision boxes of hit character in the world to locations from package frame that we find out in the previous step. When we are doing a line trace by hitbox collision channel, if there is a blocking hit, we also apply damage modifiers based on the type of physical material. After we made a line trace and check the hit, we have to return collision boxes of enemy character to original place. SSR logic works in one frame, so we can safely return hit boxes where they used to be originally, using reset hitboxes method. Let's return to beginning in server score request method. If server side rewind return confirmed hit, the only one thing left is applying damage on server. And guys, that's completely overview of the hit scan server side rewind algorithm. The next type of weapon is projectiles. I'm going to discuss it briefly since there isn't much differences. This type of weapons, as it says, uses really floating projectiles with applying physics, so we can't just make a line trace and confirm hit. We need to consider gravity. In order to do that, I applied projectile predict logic of gameplay static class instead of a line trace in confirm hit. The next steps are identical to those for hit scan weapon. The last type of weapon is explosion and projectiles. The hardest part here is that this type of projectiles explode and makes radial damage to all characters within a sphere. For this type of projectile I used prediction again as it applies gravity. We need to check if it is colliding with a world static object first. Then if it is colliding we make a sphere trace and check and return all actors within a radius. I separate this logic to my gameplay statics class in order to use it statically in different classes for the future. If characters were hit on local client machine and hit by a sphere trace on a server, we apply radial damage with follow. Again, I do it with my custom gameplay statics because I want to reuse this logic for other classes. So that's all for this video. The very last thing I want to say, suicide rewind can be very hard to implement and understand, but it's essential algorithm which is used in biggest AAA games like Call of Duty, Battlefield, Fortnite. Understanding of lag compensation algorithms in general is very important for smooth player experience. Thanks for watching. Ciao.